technical session, which is based on cement plant machinery and project engineering and advances in grinding system. We are honored by the presence of Shri Puneet Arora, President Projects JK Cement Limited, and Mr. Detlef, Managing Director Loesche. Now I would request Shri Puneet Arora ji to please come on the dais and chair the session. I would also like to invite Mr. Detlef to please come on the dais and co-chair this session. To represent NCB, I would like to call Shri G.J. Naidu, General Manager NCB, to please come on the dais and take this session forward. Now it is requested that certificates would be given to all the presenters. They should be seated till the end of the session. Thank you.
Ladies and gentlemen, good afternoon. Right after lunch is not a great time to start these kind of sessions, but here we are.
Good afternoon. This session is on cement plant machineries and project engineering and advance in grinding systems. We are honored to have Shri Puneet Arora ji and as a chairman, and Mr. Bukle as co-chairman for chairing the session. And I request the chairman, please take out the session, please.
So starting the session, I'd like to invite Mr. Michael Janzer and Aqueel Ansari from CemProTec for clinker cooler efficiency and future cooler technology for sieve capture.
Okay. Gentlemen, my name is Michael Janzer. I like to talk about clinker coolers. Can we get it on the screen? Okay. Where do I get forward? First of all, as we know, the clinker cooler is a cross-flow heat exchanger. Cross-flow heat exchanger means we have the clinker moving from left to right here, and the air penetrates the clinker bed. As we know as a technician, the best efficiency is reached if we have 100% transport efficiency. So any mixing of the clinker bed will deteriorate the cooler efficiency. So this is something we have to keep in mind when we think about cooler first. I want to talk about the achievement of cooler efficiency, introduce our clinker distribution system, the static grade CDS, talk a little bit about the smart glider, and there is a very special point, the hot air recirculation, would I like to evaluate. And then we talk a little bit about carbon capture and our revolving disc cooler. So first of all, the static grade is the most important part in the cooler. If the static grade doesn't work, the cooler cannot work. What is the purpose of the static grade? It should mix the clinker, it should fluidize the bed. So for the fluidization, we need a lot of air. We have to make sure that this fluidization can happen. And we believe that the best can be done if we have a counter pressure of about 75% of the clinker pressure on the grade system. As you see it here, we assume we have 450 millimeter on the first row, 550 on the last. So let's consider there is a 500 millimeter bed with an aerated air density of 1.25. So we have about 65 millibar pressure from the clinker bed. And if we get 47 millibar pressure between the grade surface and the clinker bed, we have this 75% counter pressure. At that level, really the clinker bed gets fluidized, and we have to retain it with the movable section afterwards. If you do it that way, you can be sure you get a very uniform clinker bed, a flat clinker bed, and the other point is it needs some time, so we also have to look at the grade loading, or how long can the clinker stay on the static grade, that this fluidization, which is the kind of work, can take place. That is very important. And when you look at these pressures here, it is of course clear that any pressure losses between the fan outlet and the grade systems are for nothing. So you just have to pay the electrical power. And here is the other big advantage. We have a multi-chamber aeration system underneath, which has hardly any pressure drop. We talk normally about 12 to 16 millibar without clinker at a specific strong air load of 2 cubic meter per square meter and second. That is important to know, and then you can really expect that you fluidize the clinker on the grade system. Afterwards, when it comes to the movable section, if we follow the cross-flow heat exchanger, it means we have to avoid any mixing of the clinker bed. So the transport efficiency becomes very important. If you look at the grade coolers, we have something like 60-70% transport efficiency. That means the more strokes you need to get to the neutral point, the more you have turmoiled the clinker bed, you have mixed the clinker bed. And that means you lose the cooler efficiency, the heat recuperation. And secondly, you have just created some wear, and if you have such a poor transport efficiency, you also can consider that you have pressed the clinker together. On the static grade, we open it up. We want to make it as easy as possible for the air to penetrate the clinker bed. So any movement afterwards that is reducing these openings will also make it more difficult to penetrate the clinker bed. The penetration of clinker bed is important. If it can be penetrated easily, we can also run a very high clinker bed. And the higher, let's say, the clinker bed, the more heat recuperation we can expect. On the other hand, it is very important that we stabilize the kiln system. And for stabilization, we have to have a certain flexibility in the cooler. So, is it from Ukraine or from Russia? We have to have we have to make sure that we get the clinker bed with a maximum transport efficiency. We have with the Smart Glider the one and only walking floor cooler without a dead layer, and that means whatever is at the bottom of the grade surface, it will be transported to at almost 100% transport efficiency towards the crusher. So no mixing can take place. Another important point is we have to look at the gas velocities. So as you see here, a huge kiln hood, an elevated first cooler roof that we have low gas velocity underneath the bull nose, and thereby we make sure that we do not return dust or too much dust back to the kiln system. The cooler is in modular design, so that makes it also for us easier to design it and to fabricate it. Design capacities is not, let's say, there are almost no limits regarding this, because we can assemble the modules side by side as per the opening or the kiln diameter, and we are flexible in length. If we talk now about the clinker cooler here, you can see this is the view from the crusher. We see on the hot section the falling clinker, and if I start the video, you see that the aeration is really smooth. We do not create any volcanoes. We do not have any dust much above the clinker bed. And this is, for me, the perfect way. We want to keep the clinker dust inside the clinker bed, which is also important if you want to take it for the mid-air, for example, for the waste heat recovery, that you have not much dust load in the system. To make sure, important is the heat recuperation. So for me, the priority is that we have the best heat recuperation, the best adjustments for the recuperation. After recuperation, we can say, okay, that is waste. How you use the waste, that is now the question. With the waste heat recovery system, you get about 20% efficiency only to get electrical power. In Germany, we have other ways to get more use of this energy. And nowadays, I see here in India more and more the hot air recirculation. Let's have a look at the hot air recirculation. We have here just the input. Above is with hot air recirculation, and we consider here 100% hot air recirculation. So we assume we have 1.9 normal meter cube per kilogram total cooling air, 0.8 goes to the kiln system, so 1.1 is hot air recirculation. If you look at the heat value of hot air recirculation and cooling air, we have 40 kilocalories. Without, just by the total amount of air, we get 17.7. That means 22.3 kilocalories maximum more heat put by the hot air recirculation. But what about the exhaust on the output? You see here, we assume, and that is really very, let's say, in favor of the hot air recirculation, that we have more or less 1/3 that goes into the clinker temperature. Of course, that is elevated. You cannot cool the clinker if you, in the middle, introduce warm air. In the vent air, you also have some elevated temperature. So at the end, you have in the middle just 7.4 kilocalories per kilogram of energy. If we calculate this in kilowatt terms per ton of clinker, we talk about 1.73. And what is the extra power? 1.5. From this 1.5, you can save 50% of it, so 7.5 you also need already by the higher actual air volume in the system. The other goes into the additional pressure on the suction side that is needed to get this air from the filter system back into the cooler. So finally, and this is really the best case I can see here, it is 0.23 kilowatt hours per ton of clinker. Now you have to see what is on the other side, the investment for it, what is the maintenance for this, and then in this best case here, I raise the question, does it make sense? Sorry, for my understanding, it doesn't make sense. You introduce something here that makes it just more difficult to get the clinker to a reasonable low outlet temperature, and this hot air recirculation, the effect is, at the end of the day, nothing, zero. But it costs you the investment and the maintenance. I would really appreciate if you think about it, if you really evaluate this, because so far nobody could really convince me that there is, at the end of the day, a positive result of this hot air recirculation. No? It just has, let's say, a compromise on a lot of things inside the cooler. If I introduce warm air, more volume, I get also more dust into the cooler system. Is it really worthwhile to do all these things, to accept this for almost nothing? Please think about it. We tried here really hard to get everything in the favor of it. As we said, we consider here 100% hot air recirculation. That is, let's say, more we can't do. If it is less, let's say it will also not look better. Okay. For the future, the question is, how do we deal with oxyfuel? For oxyfuel, we have to have a cooler that can work with two gases and has to separate the gases. That means I need a tight compartment system underneath. All the coolers in the market so far are not tight. A great cooler has these movable gaps and the side gaps, a walking floor. We still have better, let's say, we have a better seal compared to the great cooler, but is it optimal? I would say optimal is if I really have no gaps in the great system. And here with this kind of cooler, it is a rotary disc. If I open, you can see here, by the way, the kiln is perpendicular to the static grate, so I can take an advantage of the clinker segregation from the kiln in a way that the first part of the static grate, the coarse clinker will be discharged, and on the coarse clinker comes then the fine clinker. So I take an advantage of the segregation on this system here. And then if we open it up, you see how simple it is. We have a static grate. That is the same static grate that we use today in the smart glider. We have here a grate system that we use also in the smart glider, but it is arranged as a disc. We have three bearing points in the middle. These are also used for the drive, so we can use here three planetary gear motors to keep the disc in rotation. And finally, we discharge the material actively on a roller crusher. So here I can assure you the underneath compartments are tight. And if we talk about oxyfuel, we have to make sure that we have this tightness. If we look at calcined clay, we have a very, very dusty material. So also here, this kind of cooler would make sure that there is no gap, there is no spillage, zero spillage, and I can operate any clinker any material bed of this calcined clay, whether it is 50 millimeter or it is 500 millimeter. I'm not forced to have there any limitations, as well as on the air. I can aerate a compartment or can't do it. It has no negative effect, there is no spillage, so I'm flexible in the operation of the system. So again, please keep in mind the cooler is a cooler and not a power generator, and the heat recuperation is the important point. Every kilocalorie or kilojoule you can save in the burning system is 100% saved. Whatever you get afterwards, it has a certain efficiency, whether it is 20 or 25%, it never gets 100%. Yeah, I thank you. Namaste.
Thank you, Michael.
Any questions?
Questions, I think we'll take at the end of the session.
Okay.
Just to clarify, we'll go through the presentations and we'll take the questions right in the end, in the interest of time. I'd like to invite Mr. Anil Kumar, Kapil Kukreja, Nagakumar and Mr. Panda for success story on of NC, the National Council of Cement Building Materials, or as PMC commissioning a tire co-processing system.
Yeah, good afternoon everyone. So I'm Anil Kumar, I'm the General Manager and Program Lead in Process Optimization and Productivity in NCVM. So before going to our project, I'll explain you what our team will do in an NCV. So to the cement industry, we do the process optimization studies and supporting the plant for feasibility study for upgradation of the project, and also the alternative fuel setups and also mandatory energy audits. So about this project, so this is the first project we had executed in PMC, and also the first solid fuel utilized in a cement plant in Oman. So the cement plant, they don't have any knowledge of using solid fuels from directly natural gas to using to the alternate fuel, that is the tire chips usage. So Oman cement plant is having the 3 number of kilns. and that is 2,500, 2,000 and 4,000. And second kiln completely manufactures the oil well cement. So we had considered line number 1, 2, 1 and 3 cement plants for the study. So as an effective measure to protect the natural resources and use the waste generated in the country, and Oman Cement initiated to use the waste tires in cement kiln system. So to fulfill this need, they had approached the NCB. So how to do this? And we started the discussion. So from the concept till the commissioning of the project, we are involved with the Oman Cement. So before putting any project, so we have to do the detailed feasibility study for the success of any project, whether it is alternate fuel or the capacity upgradation or energy improvement. So feasibility study, what are the steps we had taken? So first we had studied the availability of waste tires with the State Department dump yard, and what are the generation every year, and then what is the chemical and physical properties of the waste tires, and also existing plant infrastructure for putting the system, and existing cement kiln operation, that is most important. So that is the alternate fuel we have to put in the system, and also bottlenecks for the system, and study of existing economics, because we are touching the ash we are adding into the system, so we have to study that, and also impact of waste tires on all the cement properties and environmental emissions, and then productivity. So the outcome of the feasibility study, so we had checked no significant impact envisaged on the production and overall heat consumption and cancer residence time. So based on that, we had arrived at the figure of 21% TSR, and we have studied about the volatile matters in the tire chips or tires, and also zinc content. So zinc is the main important criteria for using the tires in the cement kiln. So based on the bottleneck of zinc content in the tires, so we are restricted to the 21%, and also based on the availability of the tires in the system, waste tires in the country. So these are the other parameters we have studied for putting this system. So, and tires, any alternate fuel we utilize, though generally we see the CO generation in the calciner or kiln inlet. So we have studied the availability of the residence time of the calciner, and also where we have to put this tire chips or tires in the system. So our suitable location is the calciner. We had studied and arrived, and then OCC was decided to go ahead with the installation of the system, tire chips storage, handling and utilization in the precalciner for the line 3. Line 3 means is having the higher capacity and it can absorb the more tire chips. So any successful of the project these are required: better techno-economic feasibility study, and then selection of the suitable physical parameters and alternate fuel with the existing pyroprocessing system, the selection of firing location, that is the most required, and then selection of available advanced equipment in the market, and then also other project planning, erection and commissioning, and the last and not the least, optimization of the cement kiln with the alternate fuel usage after post-commissioning. So CFD study we have done for identifying the best suitable location in the pre-calciner. So this is, many cement plants don't do CFD studies, they just put the feeding location and start the system. So it will impact our kiln operations and generate the CO and falling in the tires or any alternate fuel to the smoke chamber, and it disturbs the whole thing. So we have studied the 3 potential points in the calciner. One second. Yeah. So these are the results. So point 1, 2, 3. So first point having the CO free time, and then second is the ratio of tire slices enter into the cyclone, that is the bottom stage cyclone, and then mass ratio of tire slices enter into the smoke chamber. That is 10% is falling in the first location, second location is the 12% is falling, and third location is 28% of tire chips is falling into the smoke chamber. So that is not identical. And also the CO generation, and these are the things. So we had identified the inlet H. This is the best location where optimized falling of tire chips into the bottom, and also the generation of the CO in the system. These are the process flow diagram we had installed in the system. So we had installed the tire chip storage for 500 tons per day, and also with the grab crane with orange peel design, and also with the conveying system to the preheater with the apron way feeder, belt conveyor with the metal detector and magnetic separator, and also the double flap valve to the calciner. These are the system we had installed: grab crane, coil storage, and then grab crane, apron way feeder, flexible belt conveyor to lift the material, and then belt conveyor with magnetic separator and electrical double flap valve. So this is the PG test results. So we are proud to say, from natural gas to usage of solid fuel, we are directly able to use 21% of TSR. This is the PG test results. Who doesn't have any solid fuel experience? With the better concept and then design of the system, we can achieve the higher TSR within the stride. This is the PG test result. You can see the first hour 1 TPH is the feeding, and you can see the after 12th hour is the 5 TPH. So this is the success. And the conclusion is, so the benefit of using alternate fuels is maximized with the suitable design of the fuel preparation, handling, and feeding in the pyroprocessing system. Thank you.
Thank you for maintaining the time. I'd like to invite Mr. Bert, Benski, Virendra, Kulkarni, and Asgar from Thyssen, Polysius, and TKIL Industries. Our Polysius cooler, clinker cooler with remarkable efficiency, Polytrack.
Good afternoon to the distinguished panel members, seniors, colleagues, and friends from the cement fraternity. Today, TKIL along with Thyssenkrupp Polysius would like to present our paper on the new clinker cooler from the stable of Thyssenkrupp Polysius. As you are all aware, Thyssenkrupp Polysius is a technology provider that provides and caters to the full range of equipment required to set up a modern cement plant. Here is a broad statistics on the plants that have been supplied with Thyssenkrupp technology, with more than 800 plants and over 17,600 installations. Kiln capacities built with Polysius technology range from a TPD of a mini plant of 600 to the mega plants of 12,000 TPD. Polytrack coolers, which is the topic for today, has been in the market for over 20 years, 24 to be precise, and there are over 140 installations spread across 40 countries on the globe. Like any other process equipment in a cement plant, the clinker coolers have undergone tremendous amount of development over the past many years. One of the prominent demands put forth by the cement plant in a clinker cooler is that they desire to have a cooler which is high in performance, compact to install, low wear, flexible in use, favorably priced, reliable in operation, and above all, they are easy to maintain. This complex list of requirement is exactly fulfilled by the advantages possessed in the Polytrack Eco Cooler, that is the new generation cooler from Thyssenkrupp. Its numerous innovative process and design elements make Polytrack a future-oriented mechanical and process technological solution. I'll just like to guide you through the evolution of the modular Polytrack cooler, which was first installed in the year 2000. That was the classical Polytrack A, followed by the Polytrack B, which was an improvised solution featuring more on the sealing efficiency, and the new Polytrack Eco, which was introduced in the year 2022. The conveying principle is in Polytrack A and B was the walking floor horizontal cooler, wherein the movement of the clinker was achieved through the conveying elements. In the Polytrack Eco, the movement of the aeration floor helps to transport the clinker cooler, helps to transport the clinker. Drive unit, the Polytrack A and B had a complex hydraulic arrangement, which was a nightmare for plant operational people. That point has been addressed in the Polytrack Eco, wherein we have a simplified hydraulic arrangement with 1 or 2 cylinders per track that are used to transport the clinker, and moreover, the pumps, the 1 or 2 hydraulic cylinders are limited independent of the length of the cooler. The hydraulic system has been optimized to 3 variants to meet every size of the Polytrack Eco cooler. configuration, we can have a single grade cooler with an end crusher. Also, depending on the process and construction needs, an intermediate cooler, an intermediate crusher, 2-grade cooler with an intermediate or end crusher can also be offered. The Polytrack A had a power consumption of around 5.5 to 6, which was slightly improved to 5.5. And with the Polytrack Eco, we can expect a power of less than 4.5 units. Conveying efficiency in Polytrack A and B was in the range of 72 to 74, which is improved to 86% in the case of Polytrack Eco. The bed height in Polytrack A and B was in the range of 500 to 600 millimeter, which has also been increased to more than 800 millimeter. Hot air recirculation, which is the call of the day and expected and desired by all the cement manufacturers in India. The recirculation is possible with a temperature acceptable of 130 degrees to all the chambers that are devoid of the hydraulic cylinders. So to summarize, we can say that the Polytrack A was developed to move away from the reciprocating inclined grade coolers to a horizontal cooler. The Polytrack B was an overhaul and more efforts were put into improving the sealing efficiency. And the Eco was introduced in the market to have a better and superior operating efficiency. This image illustrates a typical 2-grade cooler with an intermediate crusher. Depending on the arrangement and the process requirement, the cooler can also be offered with a single grade arrangement and a crusher at the end. The main segments or assemblies of the cooler underneath the aeration plate can be classified as the support structure, the drive block, the bearing block, the aeration chamber, the hydraulic drive, and the support roller bearing to support the aeration carriages. Static grade. The static grade fulfills several key requirements or operations desired in a cooler. It receives the material from the kiln on the upstream side and distributing it or spreading it uniformly across the width of the cooler so that you can have a homogenized cooling effect. Quick initial cooling of the clinker faces so that the highest product quality is maintained, and enhancing the heat recovery to the kiln and calciner so that the expense on the fuels can be kept to the minimum. The Polytrack Eco static grade is an optimized geometry to improve the lateral distribution. The shock blasters which were used to convey the clinker to the downstream side are no longer required to be placed beneath the aeration plates. And lastly, a refractory step between the static and dynamic grade minimizes the dead layer on the static grade, thereby helping in the motto of lower power consumption. New aeration elements that are providing superior air distribution at lower pressure drops. The aeration plates are permanently covered with a cold layer of clinker, thereby providing an autogenous wear protection system and thereby providing an extended life of the aeration plates. The first plates that were installed with the Polytrack cooler had to be replaced maybe after a duration of 9 to 10 years, nearly a decade, not on account of wear, but due to opting for a better energy efficient design. The first two images that we can see here are of the conventional or the classical Polytrack A cooler, and on its right side we have the new Lebrun seal design. The old plate had a had a solid plate and a perforated plate placed one above the other in a U-shaped design, providing constricted area of air entry, whereas in case of the new design or the Lebrun seal design which we see here, it has a higher opening area so that a higher air influx can be provided to the clinker layer above and thereby providing a better cooling effect. So the benefits of the new aeration element, as we can see, is that up to 60% higher cooling area is available. We have superior air distribution and no material blockages in between the gaps. Because of no material blockages, we can operate with a lower pressure and a lower power consumption can be achieved. The new Lebrun sealing design ensures that there is no clinker spillage, and moreover, due to better operation, we can expect a longer lifetime on account of low wear and low maintenance cost. This image depicts the arrangement of an aeration plate over the aeration carriages. The aeration carriages of the Polytrack cooler are of standard dimension 4800 mm by 500 mm, and the size is maintained across all variants of Polytrack Eco, thereby maintaining the motto of modularity and minimum inventory concept. Here we see the sealing arrangement between the moving tracks. From the initial contact type horizontal sealing arrangement provided in Polytrack A and Polytrack B that were fixed in position with the help of springs, we have converted into a new design of double labyrinth seal, that is the M and U shape arrangement. This labyrinth seal is made of wear resistant, or this labyrinth seal is made of casted material so that it is resistant to wear as well as high temperatures. In this video we can see that all the tracks move simultaneously in the forward direction, and when retracting back we can see that every third track moves back so that the clinker layer is not disturbed, and thereby we can get a better conveying efficiency. The support structure, the different aeration chambers are separated from each other by the help of partition walls that are equipped with a felt seal so that the aeration carriage's movement in the back and forth direction can be maintained, and at the same time the pressure chambers of individual chamber can be maintained as per the operational needs. The hydraulic drive, each carriage is driven by up to max 2 cylinders independent of the track length. All hydraulic cylinders are of identical size, that is dimension as well as stroke length, so that interchangeability and modularity and minimum inventory can be maintained. The complete frame or the aeration carriage is supported on the support rollers, that is providing the smooth movement in the back and forth direction as per the track movement. This time-tested, reliable roller bearing arrangement has been taken from the repole cooler, which has been in operation since ages in the industry. Hydraulic unit, the heartbeat of any hydraulic drive in the cooler. This the hydraulic drive is of European manufacture, and it is an extremely robust and reliable equipment. We are offering an open loop hydraulic system that consists of 3 standard sizes. Extremely precise track control movement can be ensured, and FAT of every unit is done before being shipped to site. The roller crusher, to reduce the clinker lumps received from the kiln and before it is exiting the cooler, the roller crushers are installed so that the desired product size can be maintained. Roll crushers are low wear, low maintenance, high performance crushing equipment adapted for coolers of every size. There is an option of opting for an intermediate or an end crusher, and it has numerous advantages over a hammer crusher. Namely, we can have an intermediate or an end crusher. Depending on the requirement, we shall always have reduced wear compared to hammer crusher, and high temperatures with an intermediate crusher can be obtained to get for the higher drying and WHR generation needs. The Polytrack cooler, more efficiency is derived up to 76%, lower clinker temperature, lower power consumption, and high conveying efficiency. More efficiency is attributed due to superior air distribution, no clinker spillages due to superior double sealing arrangement, standardized hydraulic units, and oxy-fuel ready. The success of any product that is launched into the market, I'll take another 2 minutes, sir. The success of a product and its adaptability is based on the results that are achieved by the equipment. This is the classical example of the first Polytrack Eco that was introduced in Germany. It was a retrofit plant. It was a retrofit for an existing old cooler. Once the cooler was replaced with the Polytrack, we could maintain the production levels, albeit go a little bit higher. The efficiency conveying efficiency was increased from 75 to 90. The power consumption fell from 5.5 to less than 3.7. The heat recuperation increased from 69 to 76% and above, and the lower clinker temperature was achieved with a lower specific air. This is the global reference list of the new cooler which had been introduced in the market in 2022. Starting from Germany, you can see that there are installations coming up right from Americas to the Asian continent. To summarize, we can say that the Polytrack Eco Cooler is an improved power consumption equipment, provides higher cooling efficiency. Recirculation of hot gases is possible to boost the HAR, boost the WHR, that too with a temperature of 130 degrees, which is not accepted by many of the coolers. Less wear, maintenance friendly, simplified modular design, low amount of cylinder per track, designed for worldwide manufacturing so that easy and fast assembly can be provided. All existing Polytrack cooler functionalities from the controllers have been adapted in this cooler. And moreover, we can reuse the aeration units, the drive units, and the housing and other components from an existing Polytrack cooler so that your capex can be minimized for an upgrade. We are present at this NCB exhibition, and you can visit us at our stalls 73 to 76 for any business queries, which we would be very glad to help you out, sir. Thank you all.
Thank you. Next, I'd like to invite the team from Christian Pfeiffer, presenting grinding and separation technology advancements, selected case studies.
Good. Thank you. It's a pleasure for me being here and talking about one of the most important things in life, grinding and separation. At least for me. My name is Tim Nowack. I'm head of technology in Christian Pfeiffer, a German company which is founded in 1925. So next year we turn 100 years, and we say we can grind it all. We don't look too much into cement, but it's our core business. We also go into construction materials grinding, industrial minerals, which means softer and very fine materials. We go into FGD and solid fuels mining, means ore processing. In 2012, Christian Pfeiffer formed a joint venture with Chandapur Group, and we founded the company Christian Pfeiffer India. And I must say, in 10 or 12 years now in the market, it's a great success story from our point of view. We have good feedbacks from the customers, and we have already a lot of good projects executed, which I want to show some of the things here. Our product portfolio is that we have mills in different variations. Our standard concept is a horizontal ball mill in different configurations, means trunnion bearings, slide-shoe bearings, and whatever, with a steel frame underneath or with foundation. Then we have even bigger mills for mining, semi-autogenous mills or autogenous mills. And the last piece of equipment which we have in grinding is our roller press. When we talk about the mills, we can say a ball mill is a very old machine, but it is still under evolutions and developments. And the mill nowadays looks differently to a mill 50 years ago. We have a very economic design nowadays with slide-shoe bearings, lateral drive, and a minimized number of holes in the shell. And we can say it's maintenance friendly and easy to operate. Inside the mill, we have the mill internals, and some people would say it's a commodity, but we say it's the equipment which grinds. Yeah? The mill is just turning, and acting is the ball charge. And the ball charge is acting because of the liners. So mill internals, from our point of view, is a process item, and definitely not only a sustainable an equipment like oil and grease. Yeah? Not working? No. Good. From the mill internals, we must say, or we can say, we have sold more than 5,000 diaphragms. And when you look in our logo, the logo is the symbol of a diaphragm. So since nearly 100 years, it's part of us. In terms of the new machine, the roller press, we invented some special features to our machine, and we are really confident and proud to announce that we have a machine ready to sell into the market, and especially Indian market I think is a focus market for us. We have already a case study to show, which is a plant in Marmara, or in Düzce in Turkey, Marmara Cement, where we installed 2 combi grinding plants in 2021. The type of material which we want to grind, or we grind, is an OPC or CEM1 with 95 clinker and 5 gypsum. We are looking for a high early strength cement, so 42.5 R. We look for a fineness of 3,800 to 4,000 plane, and we look for this 210 tons per line. We have installed 2 lines simultaneously or at the same time. So here we see the ROP, but the ROP is a part of a circuit. The circuit here, we call it advanced combi grinding, which means we don't have a special separator for the ball mill. we normally make this as a greenfield installation, or we are eliminating an existing separator from the existing ball mill, and then we form this advanced combi grinding circuit where we have one static dynamic separator configuration. This, we believe, is the most economical way of making this roller press grinding in combination with the ball mill. Here's some operating results. We see on the roller press the specific power consumption is about 11.9 kilowatt hour per ton, while the circulation factor over the machine is around 5, which means we have more than 2 kilowatt hour per ton energy uptake per pass, which is, from our point of view, a good number. With the ball mill, we continue with the fine grinding, and here we needed a 16.1 kilowatt hour per ton, and so in total we reached 28 kilowatt hour per ton on the milling devices, reaching 185 tons per hour during this test period, which is not the 210 obviously, but it was at 85% of the roller speed, so it was not under full load. The plane was on the upper limit, 4,000 plane, and residue values were very low, 3 to 6% on 32 micron. So a very low number on 45. Strength development, we see the table on the right, or the graph. We see 54 Newton or a megapascal after 28 days, which is in line for 42R. Grinding plants, Christian Pfeiffer sold more than 100 complete new grinding plants. Coming now to the other topic, which is the separator. We say a dynamic separator is the mother of the circuit, I would say. And these dynamic separators are all cage separators, but with different configuration. The first one, the S, is that the finest leaves the separator on the bottom by the gas, with the gas. The T is the one with the top exact, and then we have an L, TKIL, which is an air-swept separator, feeding the material included in the air, which comes from the bottom. And then we have this combination static dynamic separator, which is basically a TKIL, but it has additional feeding points to the top. So it's a twin feed separator, and this is why we call it a twin feed separator, TKF. Other types of separators we have also in our product portfolio, which is for vertical mills, so TKM and the TKK. The K version is for explosives, so normally ATEX conform and used for smaller coal grinding plants or coal mills. And of course our old traditional separator, which is the first generation height separator. New in the field, specially designed for industrial minerals, but now also coming into interest for cement industries. For the cement industry is the so-called ROC, the revolutionary separator, and it is looking for a finer top cut. Yeah. Then we have also different versions. We have the T for top feed and then L for this lower feed. And the UROC is then another specialty, which is a horizontal cage separator. Yeah? But it's limited for very fine particles, which we want to achieve, and non-abrasive particles. Because the rotor you cannot design in a proper way and wear resistant. Yeah? So this is the limit here. Getting the best out of the separator, I would say, from my point of view, looking for a G-force, so the centrifugal force applied by the rotor speed, minimum 115 times the G-force, which is good enough to achieve 5,500 plane without reducing the air volume in the separator. We need an optimized material distribution. So dealing with high circulation factors, thank you, we need the optimum distribution. We need the possibility to adjust the flow rates, and from my point of view also important, shearing forces. So the distribution table, applying shearing forces to particles is minimizing agglomerations. Here we see the range of the top cut of the separator types, where we see between the rock and the U-rock, there's also only a very small, finer edge on the left, from 5 micron to 3 micron, but it's a complete new world from the job what the separator has to do. In terms of G-forces, we talked before 115 G, the U-rock goes up to 6,000 G. The case study 2 is an example of this rock T, where in India we have a customer for JSW cement superfine slag separation installed this year. So we feed grinded material, ground slag material to the separator, and we take the fine fraction out. Our target is D98 9 micron, Blaine above 10,000, and production rate on the fine side 5 tons per hour. Some other case studies here, JK Lakshmi, where we have existing plants, cement mill 1 and mill 2 are existing plants reaching 75 tons an hour with 36 kilowatt hour per ton, and we put a new line there with our Kudika S separator, but same mill dimensions, reaching 29.9, so 30 kilowatt hour per ton and 95 tons. Coal grinding, we see production increases by changing the coal mill separators, 12, 10 and 13% increase of production. So we talk not so much about the product. We need product, yes, but our heart is the process. We want to give you the better solution, the better concept, and this is why we say we are more than just grinding and separation. We look for efficient processes. Thank you.
Good afternoon, distinguished guests, colleagues and professionals. It is an honor to be here to present the success of high-pressure grinding roll Polycom with studded and compound cast roll tires. In present scenario, HPGR in finished mode for raw material grinding and HPGR in combination with ball mill for cement grinding are well known for their power savings. However, our focus here is also to help you out to select the suitable wear protection concept for HPGR based on its application and raw material properties to achieve the unmatched reliability, efficiency and performance. Okay, these are the key topics that we will discuss in the next few minutes. Now let us understand the market trend and highlighting the presence of HPGR. Until year 2000, VRM occupied the 90% of the market share. However, HPGR and other technologies occupied the 10% of the market share. But due to the advancements, the technological advancements in the HPGR system and the salient features of the HPGR system, the market share has increased to 75% in case of raw material grinding and 50% in case of cement grinding. Now, what are the key features? Let's understand the attributes highlighting the key features of the HPGR technology. First, we will understand the working principle. The working principle is HPGR works on the high pressure interparticle combination, wherein which the material is fed in between the two grinding rolls, that is counter rotating in clockwise and anti-clockwise direction. The material to be ground is fed in between the rolls, and the pressure, the grinding pressure is transmitted via the hydraulic system through the floating rolls. This is one of the animation. Okay, now in case of HPGR system, the material to be fed to the separator is transmitted via the external system, bucket elevator, whereas in case of VRM, the material is fed to the separator pneumatically, that is internally. So here the requirement of the specific air requirement and the high velocities into the VRM lead to the pressure drop across the VRM and increases the power consumption of the fan. Let's understand that in case of VRM, the compressive forces and the shear forces are working for the grinding action, whereas in case of HPGR, it is purely the compressive force. As the shear forces in the HPGR are minimal, the roller life achieved is better compared to that of the VRMs. Now, what are the challenges that are faced in the raw material grinding and cement grinding technologies with HPGR? First is the selection of the roll surface, and the second is the limitation of the commonly used forged and hard face roll surface tires. HPGR outmarks the VRM in terms of the performance, as the grinding pressure in case of HPGR is 5 times that of the VRM. And talking about the limitations of the forged and hard face roll tires, it is, the achieved wear life is less in case of abrasive raw materials, and also in case of cement grinding, due to the requirement of higher grinding pressure, there are chances of the fatigue failures and unplanned stoppages. So let's understand the wear mechanism of the HPGR system. You can see the pressure distribution profile. If the unplanned and ununiform feed results into the peak pressures, which creates the unusual high stresses. These stresses can, lead to the chunking in case of the forged and hard face raw materials, as the maximum pressure can, exceed the yield strength of the base material and that of the coating. So here you can see the images that the peak pressure may lead to the chunking of the material in case of forged and hard face roll materials, leading to the unplanned stoppages. Hence, the selection of the hard layer with a compressive strength of more than 2,800 is required. So now what do we have to offer as TKIL? So we offered the forged and hard face roll bodies, then the compound cast roll bodies, and the forged roll bodies with the studded rolls. So these are the key parameters. The multi-layered hard facing. Talking about the forged and hard face roll bodies, multi-layered hard facing is onto them. Autogeneous wear protection is achieved in between the rolls. Then the expected wear life is low due to the fatigue strength and the damage by the peak pressures. However, here the maintenance can be carried out in situ. Then talking about the compound cast rolls. In case of the compound cast rolls, that is the best available technology so far. Durable compound cast, then the ductile main casting and the outer hard layer, which has a very high compressive strength. Autogeneous wear protection is achieved between the profiles which are welded onto the roll surface. There is no failure due to the material peak pressures and the fatigue. Then talking about the hard studded roll bodies. In case of studded roll bodies, the base material remains the same as that of the forged and hard face roll bodies. However, the studs perform the grinding action, and the autogeneous wear protection is formed in between the studs. The expected wear life is lower as compared to that of the compound cast. However, it is better than that of the forged and hard face roll tires in case of highly abrasive raw materials. Then the proper wear protection. Now, how to select the proper wear protection for the polycom based on the raw material properties. Now, based on the raw material properties for the mildly abrasive raw materials, the specific grinding force in case of raw grinding is 4,500 to 5,500 kN per meter square. So here, the wear rate of the raw material grinding or the raw material properties is less than 4 grams per ton. So the forged and hard face roll can suffice the purpose and give the wear life of around 17,000 hours. Whereas in case of highly abrasive raw materials, the specific force requirement remains the same. However, due to the highly abrasive nature of the material, the achieved life with rates of forged and hard face roll tires is minimal. Hence, it is recommended to go for the studded roll bodies, and the expected life can be around 25,000 hours. Then for clinker grinding application, due to the high pressure requirements, as the clinker is hard in nature, the compound cast are preferred. Then secondly, the specific grinding pressure is higher, 6,000 to 7,000 kN per meter square. Then compound cast can deliver an exceptional wear life with a life of running hours of 35,000 hours and greater. Then let's analyze the real world applications of the polycom with studded rolls. At JSW Cement Shiva, we had supplied polycom size 22L8 with a motor rating of 14,550, 1450, and the warranted capacity was 340 TPH at less than 1.5% residue on 212 micron. And you can see the achieved performance, it is 364 TPH at less than 2% residue on 212 micron. And the power saving is very considerable, which showcases the measure of our success. 11.10 was the specific power consumption for the core equipments, and the achieved figure is 7.25 kilowatt hour per ton. The circuit is in operation since 2023. Now let's have a look at the profile maintenance that is being carried out. The typical roll profile maintenance for the abrasive raw materials is as follows. For forged and hard face roll tires, after every 4,000 hours, the profiling and the side facing needs to be carried out. We have just indicated the number indicating the requirement of the electrodes and the wiring metals. So the downtime here expected is 4 to 5 days, which can increase if the damages are considerable. Then after every 6,000 to 8,000 running hours, the weld buildup is to be carried out on the forged and hard-faced roll tires, and depending upon the roll conditions, the expected downtime can go up to 15 days. Then, as explained earlier, for the abrasive raw materials, the wear life that is achieved with the forged and hard face is 17,000 hours. If we compare that with the studded rolls, a regular inspection and the minor maintenance of the studded rolls, can bring out the best in the studded rolls. And the achieved life can go up to 25,000 and beyond. Then 2 cycles of the forged and hard face roll tires are required for the same duration of 25,000 hours. If we collectively see what is the downtime that is required in case of the forged and hard-faced roll tires, it's 45 days, whereas in case of the studded roll bodies, less than 7 days are required for the maintenance if carried out properly. At JSW Shiva, presently, you can see in the figure that the autogenous wear protection in case of studded rolls is very well. There is no maintenance, no downtime presently. The running hours achieved are 6,800 without any maintenance, without any downtime due to the studded roll maintenance. And on account of this, if we collectively see the availability of the system, the achieved wear life, the payback for the studded rolls can be less than 4 years. So this makes it the best solution to go for in case of abrasive raw materials for raw material grinding. The availability of the polycom is improved considerably. Now, second, compound cast roll tires. Now, Ultratech Cement Dalla, Uttar Pradesh. So here we have supplied the polycom with compound cast roll tires. These are the key specifications of the polycom and the separator. Now let's talk about the achieved performance. The plant is in commission since 2022, and the performance that was guaranteed was 205 TPH at 3,800 Blaine with a combination of fly ash PPC production, that's for sure. So the warranted specific power consumption was 24.5 kilowatt hour per ton for the complete circuit, and the achieved is 22.75 kilowatt hour per ton. So the statements made earlier regarding the power savings, those are visible in the real world applications. Similarly, if we compare the maintenance profile for the forged and hard-faced roll tires in comparison to the compound cast, the cycle for the frequency of the wear protection is similar in that case of clinker grinding because of the higher pressure requirements in clinker grinding. So the cycle for forged and hard face remains the same. However, if you see in the compound cast, after every 6,000 to 8,000 hours, a minor more profiling or the intermediate profiling is to be carried out. The indications are already given. And if we compare the overall effect after 35,000 hours, the downtime compared to the forged and hard face, which is 65 days in case of clinker grinding application, is less than 25 days. Now, the hidden advantage in the compound cast roll tires is the acceptability of the higher specific grinding force. And that is contributing to the higher 2% of the production compared to that of forged and hard face roll tires. The running hours that are achieved is 13,300. There is no cost incurred due to the maintenance till date. The profiles are intact. There is an enhanced system availability. Enhanced production capacity of 2%. Like I said, since the high pressure requirements in clinker grinding, there is an acceptability in compound cast that it can go for higher specific grinding pressures. On account of more maintenance in forged and hard face tires, lower production is due to the reduced grinding pressure, and the payback for compound cast roll tires can be assumed less than 2 years. The compound cast rolls supplied at various locations in India have achieved 50,000 hours and are still running. So, the key insights and takeaways of this presentation are that if you are in search of reliability, then for raw abrasive materials, studded and compound cast is your option. Thank you. So, we are also available at our stalls. You can visit us for any further assistance. We will be happy to help you out. Thank you.
Thank you. The next presentation is on KHD pyro process. Jens Bredenbach and Anurag Johri.
Okay, good afternoon. First of all, I would like to thank NCB to inviting us to this session. A very warm welcome to the audience. Today you are quite lucky because in the next 15 minutes you get, for the price of one presenter, you get two presenters. So my name is Jens Breidenbach. After the first section of our presentation, I would like to hand over to my friend Mr. Anurag Johari. And today we would like to present about KHD low-hanging fruit when it comes to optimization of pyro process. So the content of our presentation, first of all, a short introduction about the company, about the overview about our pyro products and expertise, for preheater development, especially in terms of efficiency, I would like to hand over to Anurag. Cooler parts development, especially for our pyro floor cooler, I would like to present, and last but not least, of course, summary and conclusion. KHD's pyro product proprietary equipment from KHD. So we are doing our own equipment when it comes to pyro processing. In terms of the entire cement production, we have to procure from other vendors, but the pyro process can be equipped with totally KHD products, preheater, calciner, kiln and cooler. So under the umbrella of the so-called Center of Excellence, we from Cologne, we are providing a lot of research and development. And we are not just focusing on the huge steps like activation of clay or oxyfuel. We still are focusing on the development of the existing products. So today, the existing product cyclones and the existing products cooler parts. So from Cologne, of course, we are supporting all our entities, and the biggest entity is here in New Delhi, India, heading by the president, Mr. Ashok Tembla, and in this team, head of process is pyro process is Anurag. So Anurag, please take over.
Yeah, thank you, Jens, for the introduction. And good afternoon, chairpersons and all the members present in the conference hall. So, like the process goes off, I will start from the preheater, and then later on cooler will be taken by the Jens. So, okay. Yeah. So, we always take proud for the continual development of our portfolio, product portfolios, and that is why today I will be presenting about the latest development which we have carried out in our preheater system, majorly on the efficiency part, which is known for it. And as we all know, the preheater cyclones are worked on these three triangular principle of the low waste gas temperatures, low pressure drop, as well as the highest separation efficiency, and equilibrium of all these three pointers will result in the good heat transfer and the overall efficiency of the system. So, since the time is limited, so I will not be going much into the details of what we have done. Majorly, I will be projecting about the after effect results, which we have obtained during the last years after implementation of these cyclones. Our preheater cyclones are well known for its efficiency, majorly in terms of the lowest exhaust gas temperatures as well as the highest separation efficiency. But the pressure drop was a concern which was comparatively high in the older series, and we decided to roll out the new series in 2010, which we call it as a HE, high efficiency cyclones, where we have carried out certain modifications in terms of geometry and dip tube sizes and the internal area ratios. And then later on in 2020, after a decade further, we have taken up this project to further optimize and improve the efficiency part of these preheater cyclones by doing further optimization in the geometry for improving the efficiency of the operating cyclones. So these are some of the results which we have done from this HE cyclone to HEM cyclone, which we call it as a high efficiency modified version. And the overall result I will be presenting in the coming slides, which will be telling by itself what are the improvements and how the end user got benefited by all these modifications. So this is the plant 1, which we presenting for a 10,000 TPD plant operating since last 2 years. And here the results are telling by itself the preheater exhaust gas temperature is coming around 245 degrees centigrade, and the preheater outlet draft is as low as only 330 millimeter water column. This is plant number 1. Then plant number 2, this is another plant of 8,700 TPD, where the exhaust gas temperature you can see further lower, around 242 degrees centigrade, and the outlet draft is only 290 millimeter water column. And this the plant number 3, that is of 8,400 TPD. The preheater exhaust gas temperature is in the range of again 245 degrees centigrade, and the outlet draft is around 330 millimeter water column. So these results itself elaborate the efficiency part which the cement producers are gaining after installing these modified HE cyclones. The lower exhaust gas temperature as well as the lower pressure drop is resulting not only the lower electrical energy demand, but as well as the lower thermal thermal energy also. So likewise, most of you must be aware about in the recent past there is news on the social media and the LinkedIn that some cement producers are installing these 7-stage preheaters also for improving the efficiency of their plant. But we here at KSD taking this step in a different way by improving the efficiencies, not by increasing the stages, but we are confident enough that we will be improving the efficiency of preheater cyclones, and we can go ahead for improving the efficiencies by reducing the stages as well. If you see the pressure, this temperature is for a 6-stage preheater is in the range of 245, and for a 5-stage preheater we can get comparatively around 260 to 270 degrees centigrade. And here is not a stoppage, we are still working on the further improvisation of these cyclone geometries, so that we are confident enough, maybe when we will be coming and presenting in the 19th NCB seminar, then we may be presenting the results by, comparatively with the lower stages of the preheater with the better efficiencies of the cyclones. That is all from my side. Now Jens will take over further for this cooler part for completing the presentation. Thank you.
Thank you, Anurag. So regarding our cooler technology, you might know KHD has 2 cooler in their portfolio. One is the Pyro step cooler, and today I would like to draw your attention regarding the improvement of our Pyro floor cooler, which is a walking floor cooler. And in particular, I would like to present the next generation of a Pyro floor cooler cassette. So as you can see here on the left side, this is our first generation design of a Pyro floor walking floor cooler cassette design. And recently we designed a new so-called ProFlow design, and this was a requirement from the market because in terms of pressure loss across the cassettes and the clinker layer, we were not as competitive as other vendors because we were always slightly higher in electrical power consumption. Therefore, we invented this new ProFlow design. How did we do it? Of course, engineering starts with CFD. So here on the left side, you see the existing old design, and on the right side, you see the new ProFlow. And with this CFD check, we tested the pressure loss across one cassette, including clinker layer, for the old design, for the new design, and we even used competitors' design. So in comparison of all 3 designs, we are now significantly lower in delta P, of course depending on the specific air load, and with this we can somehow gain this less power consumption at the cooling air fans. So the second step in developing these new cassettes were the laboratory test. Here you see a test facility in our laboratory in Cologne, Germany. a very simple setup, but to go into the market, to go into the fields, we try to do not just CFD analysis, also laboratory test to convince ourselves and of course our customers with the results. Yeah. So the laboratory results were somehow matching with the CFD calculations, as you can see here. This is according to a ProFlow design in greenish color, and the blue color is the current design, the original old design of our PyroFlow cassettes. So as a conclusion, every cement producer, of course, is driven by optimization of the efficiency and reducing production cost and carbon emissions, of course. And we, even with optimized design of existing equipment, try to catch up, to reduce fuel consumption, to reduce electric power consumption, and save capex cost. And especially the electric power consumption will end up in reduced carbon dioxide emissions, because electrical power consumption is linked to CO2 emission. So as a general conclusion, KHD Cologne and HWI in New Delhi is continuously improving their products in regard of the above mentioned goals for the cement producers. So thank you very much, and I would like to invite you to our booth in the exhibition hall.
Thank you. Last presenter this session is Venkatesh Vanam, a roller press technology boon for existing plants.
Respected chair and co-chair and the dais, ladies and gentlemen from Cement World, good afternoon everybody. In the previous presentation, you have seen the technological advancements from our company in pyroprocessing systems. In this presentation, you will see about our roller press technology. I would say roller press is a boon for the existing plants to transform into greener and more efficient. It is clear in the last 2 decades, cement industry is not opting for standalone ball mill circuits due to high energy demand. As there is a lot of pressure on the cement manufacturers to reduce the carbon footprint, it is the right time to transform the existing ball mills into more greener and efficient. To transform these existing plants, roller press technology is the only solution available in the market. KHD roller press doesn't require elaborative introduction, as it is well proven in the last 2 decades for all the applications, be it raw metal grinding, cement grinding or slag grinding. Roller press is quite simply the most energy efficient grinding machine in the market, and KHD was the company to introduce it to the cement industry. We are having different sizes of roller press from 7 meganewton to 27 meganewton grinding force. We have standardized our roller diameters from 1.7 meter to 2.5 meter, and roller width we have standardized from 0.9 to 1.8 meter. What are the key benefits with roller press circuits? It offers lowest specific energy consumption in comparison to other comminution technologies, including VRMs. With lowest specific energy consumption, we are having lower operating costs, high levels of reliability and availability. This machine is suitable for all the grinding applications, be it raw material grinding, clinker, or slag. Our circuits are suitable for highly abrasive materials and wet materials, which are having high feed moistures. Coming to the important aspect, that is roller surface, we are having 3 different surfaces. The first one is welded surface. We call it as complete outfacing CHF surface, which requires welding during the operations. It offers the balance between lowest investment and wear life. For low wear rates, we use this welded machine, welded surface. Second surface is stud roller. We have seen this from our competitor also. Stud roller, this arrangement gives autogeneous wear protection in between the studs because of its arrangement, and it offers superior nipping properties, thereby we can increase the grinding efficiency. These studs are with tungsten carbide material. The latest surface from our company is high chrome bandage, which is a compound cast material. This profile application method is very advanced. We grind the profiles instead of welding onto this high chrome bandages. Here you can see different separators from our separator family. V separator is a simple, static, and revolutionary innovation from KHD, which changed the efficiency of high pressure combination circuits. The first static separator is V separator. Right side you can see other static separator, we call it as LS separator. This LS separator is used for the final product, which we recommend for the raw metal grinding application. With the use of this static separator instead of dynamic separator, there is a energy saving. It can be from 0.8 to 1 kilowatt per ton of raw material. So this is suitable for raw mill application where the residue requirement, product finance requirement is up to 10% residue on 90 micron. It's not okay. Yeah. On the right side, you can see the dynamic separators which are in offerings from our company. The first one is SKSL. Here, the material along with the gases is fed from the bottom. Second one is SKSV, Z. The feed along with the gases is fed from the side. There is a need to transform existing plants into efficient, greener. The new carbon footprint reduction policies are forcing cement manufacturers to offer greener technologies. At the same time, there is a need to transform the inefficiency of the existing plants into more efficient and greener. To pick up one, there is a scope for improvement of existing ball mills used for cement grinding application. These plants can be upgraded with roll press system to achieve specific power consumption reduction and production increase. Mainly in brownfield expansion projects for cement capacity enhancement, be it integrated unit or split grinding unit. So there can be 2 choices. One is addition of a new cement mill circuit, and the second one is upgrade of existing ball mill circuit with installation of roller press. So what is the main advantage of upgrading the existing ball mill with roller press? The main advantage is capex is lower with ball mill upgrade solution in comparison with the new cement mill circuits. Why? We can use the existing feed hoppers in most of the cases. When we upgrade the existing ball mill, so there is an increase in the feed requirements. So for this, there can be a necessity of maximum 1 additional hopper for clinker. The conveying arrangement can be retained as per the existing setup because we are using the existing feed hoppers. The conveying existing setup can be used, but for the increased production figures, there can be a necessity of modifying the conveying capacities. And product conveying arrangement is also much optimized with a single product from the circuit. Coming to other advantages, apart from the capex, there is a production increase up to 200% depending on the selected roller press size and ball mill size. Specific power consumption reduction can be up to 6 kWh per ton depending on the selected roller press size and cement type produced. It is because roller press consumes electrical power around 50% of the ball mill. By upgrading this one, the inefficiency of the old separators, which are due for replacement, is eliminated with new highly efficient separators from us. Now it is a time for blended cements to reduce the carbon footprint. When blended cements are in picture, we may use slag, we may use wet flash to meet these drying requirements, which was not possible with ball mill. These drying requirements can be met with the roller press circuit with the use of V separator. At the same time, the cooling requirements in existing plants where the clinker temperature is very high, where we cannot handle such high clinker temperatures in a ball mill without water spray, that can be done with the roller press circuits. In a V separator is a multifunctional which can be used for drying and cooling. In case of cooling, we use the ambient air to cool the high clinker temperature. And there is always a flexibility to run RP in finished mode or semi-finished mode. When there is a market demand is less, we can operate the roller press in finished mode without the ball mill, thereby reducing the specific power consumption. So when we upgrade a ball mill, there can be two solutions which we can offer. So there is the picture which you are seeing, we call it as internal nomenclature B type. There are two dynamic separators. Means we are retaining the dynamic separator of existing ball mill circuit. If the efficiency of the existing dynamic separator is good, we can use two dynamic separator system. Here the dynamic separator of roller press circuit is only designed for throughput of the roller presses. So we have to ensure proper mixing of these two products before entering the cement silo. It's not. Yeah. So second solution is we call it as S type. It is a single product system. Existing dynamic separator of the ball mill is not used. New dynamic separator is designed in such a way that it will take care of the throughputs of roller press and ball mill. Let us have a look at one case study. Ultratech Irmi Cement Works, cement mill 1 upgrade with a roller press. So there were two identical ball mill circuits for cement grinding along with the line 1 clinkeration plant. When the group decided to go for line 2, it was decided to upgrade one of these two ball mills with KHT's complex circuit. The existing ball mill was 4.4 meter dia with SEPAC separator in closed circuit. And producing about 140 TPH OPC at 2900 plane. For this upgrade, we have selected a RP model RP20 170 by 180. This is the process flow sheet for the upgrade concept. If you see what are the equipments that we have used the existing 3 feed hoppers, 2 minutes, sir. Existing 2 wave feeders, and we use the belt conveyor feeding to the ball mill. It will be used only for the wet flash. Complete ball mill was used as it is, only double chamber mill converted to single chamber. Ball mill vent fan, filter, ball mill recirculation elevator were used. These are the main equipment sizes for this upgrade concept. These are the performance guarantees as per the contract. For OPC, we have given a production of 290 TPH with a delta increase of 150 TPH. And for PPC, the guaranteed production was 380 TPH with a delta increase of 190 TPH. And coming to the power consumption, we have guaranteed a delta decrease of 4.5 kWh for OPC and 3.3 kWh per ton for PPC. And during the PG test, client opted for performing guarantees on PPC, and we have met all the guarantees. These are the latest upgrade references from KHD in India. If you see, there are about 10 in the last 3 years. The particular model, RP model, which was used for all these upgrade projects is 170 by 180. To conclude, there is a necessity to improve the efficiency of the ball mills, and high pressure grinding roller press is the only solution for this, for more information and detailed discussions, you are invited to visit our stall number 21, 22, and 23 in exhibition hall. Thank you. Thank you very much for your patience.
Thank you. I'll invite all the speakers to please come up on the stage and take any questions that the audience may have. You're welcome with your questions, please. Any questions? Yeah, there's somebody at the back. Can we have a mic passed on?
I have a question with KHT, pyro processing. So in our Shri Cements, Kodla plant, the top stage cyclone pressure drop is very less. It is around 20 to 30 mm, okay? Less than 20 mm. And the temperature is also less. But only problem we are facing is with higher return dust. Dust collection efficiency is very poor. So I just want to know, with very minimal pressure drop, I think we are not meeting the sufficient riser velocity. So that we are facing the issue with inefficiency in dust separation. So could you just...
Did you understand? Yeah, he was talking of Kodla.
So with low pressure drop, I mean the dust separation is, higher side, return dust.
See, when we talk about particular to your project in Kodla, it all depends upon the configurations for the capacity requirements. And the very first indicator for the cyclone efficiency of the overall preheater system, not the pressure drop, but the outlet temperature as well as the return dust. So if the outer temperature is in the control, like I was projecting in the slides, return dust is also not that much high. It is more than around, I think, more than 96% of efficiency. But for your particular case, we have to, look into the subject in detail, why it is coming so high. What is the exhaust gas temperature you are having?
Exhaust gas temperature is only 255.
255.
I mean, that is running excellent. Heat, specific heat is very less. Only the issue is with the dust. Return dust is very high.
So maybe for a particular case, we have to investigate in detail separately why it is happening. But in general, it should not happen like that.
Is it, just want to know whether the design is very low pressure, like how much, what is the minimum pressure drop required in the top stage?
Pardon, can you repeat?
What is the minimum pressure drop required in the top stage cyclone?
Minimum, see, that is what I said. Now, on the configuration basis, it should be in the range of minimum 50 to 60 minute water column for the top stage.
Right. So, as per our, the dip tube, we are just having 46% of the height. So, whether can we further extend the dip tube?
No, not like just by, optimizing the dip tube height. It has to be investigated in total detail because your configuration is completely different for a given capacity, what I know. In Kodla plant is a 3-string preheater and for a capacity.
Okay, we will discuss, sir.
Yeah.
Thanks.
Good afternoon all. My question again to Anurag. Anurag, you have shown nice slide where you have shown 330.
Can you speak a little louder?
Hello. Yeah, my question to Anurag again. Anurag, during your presentation on pyro processing.
Mic close to your.
Can you please? Yeah.
You have shown the slide which is having very nice figures like 330 mmWg at preheater outlet temp, pressure drop, and temperature 245 degrees centigrade. So can you share with us on which plant these parameters are operating and cyclone configuration you can show with us?
Yeah, obviously we can discuss in our booth and give all the details, whatever is required to give where we are operating like that.
Yeah, there is one more little bit funny question, but see, in the slide you are showing very nice figures. When we are asking for the offer to us, these kind of figures, that time you are not offering us.
See, that is altogether a different story for the post-contract and operation and all. But this is what I was showing as an end user, what he will be getting. See, putting on the number is not a question, what we are putting. Major thing is what you are achieving. That is what you are gaining over there.
No, that is thanks to your pyro that is operating very nicely, even better than your expectations. Okay, thank you.
So let's take this offline, I think. So one last question and then...
yeah, good afternoon all. This is Atanu Bhattacharya from KHD. My question is to my friend Ali regarding the Polytrack cooler, Eco especially. Just two things I need clarification. What is the additional thing which you have done? You rightly said, maybe I don't know, you probably didn't say it rightly, but you said that there is a lot of problems with the cooler, earlier version of Polytrack. There was a lot of fall through everything. So what is that you have done special for the new cooler? And the second question is, how did you take care of the HAR in the cooler new generation?
Thank you, Atanuji. There were problems reported in the Polytrack cooler, the earlier version, the classical Polytrack A that was introduced in 2000. But problems of spillage was not reported on every plant. There were specific plants wherein there was fine granulometry of the clinker and where was observed in the horizontal sealing arrangement. That is overcome with the new double labyrinth seal, that is the M and U arrangement. That takes care of it. The fine clearances and the machining is taking care of the fitting arrangement for that particular application, sir. So that has been reported, and unfortunately I cannot share it because the customer has not given the permission. But I would be glad to share the...
Yeah, it's okay.
Just allow me to complete. I would be glad to share the operating results of the plant from Germany, wherein even after operation of 1 year, there has been no dust spillage, nothing, no fine dust has been reported. It is as clean as it was installed. And could you please come to the second question again?
The second one was regarding the hot air recirculation.
Yeah, the hot air recirculation is that which is the need for every cement plant in India nowadays. Hot air recirculation is taken care of, and moreover we can accept a hot gas temperature of 130 degrees on a continuous basis to all the chambers that are devoid of hydraulic cylinders. Now this additional temperature takes care of whatever chambers the hot air is not supplied to. Moreover, in case there is a surge in the hot gas temperature, we can accept a temperature of 150 degrees for a duration of say 24 hours.
How did you protect your hydraulic systems?
I like to, let's take this offline for the rest of it. Yeah. Thank you, gentlemen, for your time and presentation. I request Detlef for his closing remarks, please.
So I've made some small notes to each presentation. Allow me this 1 minute, please. So in regard to clinker cooling efficiency, this was rather a bit theoretically case studies, the existing installations and proof of data, that is what I was missing. The second presentation, the usage of tires, that was of course quite interesting. The problem with this is you won't get tires in India which you can use in the kiln process. Therefore, in Germany we use it, but I know also in Germany it is not possible. Coming to the clinker cooler Polytrack, also here it was missing how many installations are there and what are the differences in cost to these coolers to conventional costs, just in percentage wise, grinding separation advantage. So all our mills are still under development and results to be awaited. What I've seen the residue on 45 micron at 4,000 blade was rather on the higher side in my point of view, but you're still working on the further development. Reliability, success of Polycom. There, of course, we as a mill supplier, I'm struggling a bit when somebody brings market share into that without any proper proof. And when I see, of course, that you need for 2,000 kilogram welding 15 days, if I calculate roughly, that comes to a very low amount of welding per day if you weld it. KHD moving ahead with green chip. There are promising steps in terms of power savings, especially at the preheaters. And coming to roller press technology, I could not see any improvement, of course in wear, yes, but not in the other parts, and especially not in classifying. But in general, thank you for the presentations. I'm quite impressed. Thank you.
I'd like to thank all the presenters for an excellent job. Interesting, like Detlef pointed out, there are many presentations on the RP, but nothing on the other, so food for thought. So I'll not delay this further. Give them.
Thank you, sir. Now I will request our chairman and co-chairman to please present the certificates to all the presenters. I would request all the presenters to come on the dais once again. All the presenters, please come on the dais. Thank you, sir. Now I would request Shri G.J. Naidu to please present the mementos to our chairman and co-chairman as a token of respect. Thank you, sir. We would once again like to thank our chairman and co-chairman for their esteemed presence. Thank you, sir. So this was the end of our fourth session and time for a tea break. The next technical session starts sharp at 4:30 in the afternoon. Thank you all.